Hey, what's up, y'all? It's Crackpot Chan in the house. We're gonna do something today. We're gonna do alien operators today, which is we're gonna do some wild logical combinations for the algebraic field of the prime automata, and just look at what's possible and see if we can't find something new in here I've never seen before, just by doing something weird with the operator. Let me go to the field, and now I've got links to this that I posted. I'll make sure this is available easily too, right here. But this is what we'll be working with right here. And right here we'll have the, right now this is showing for mat primes on the XOR field, but we've got the FFT phase. Now these will get really insane. I'm not like freaking out over these right now, but internally, like I still am. Don't make no mistake. And I mean, this thing is just, it looks just 3D. It looks fake. And it's literally not. Like, that's what makes making it. That's just diagonal frequency. We see, let me get my, trusty pen. So we got, that's real interesting. I actually haven't seen that. This now, some of these I'm trying to figure out if it's an artifact of the grid. Some of these now, like this 1.4 appears everywhere. That's the square root of 2 approximately, and that's 498 billion. That's a wavelength apparently in here. That's an invariant too, not the actual number, but that scale. I think, but that scales with the grid. So it's either an extremely profound metric about like long range order of the primes, or whatever thing we're looking at here, like this correlation length. Sometimes it's a small number, but this is pretty big right here. So long range order, and we're looking at the Fermat. Fermats have a really small density, yet ridiculous order, right? Negative angles, you don't see those a whole lot. So my idea is just to let you know what my goal here with these is. It's like backdoor metrics. There must be some type of, and there is for sure, bridge to, right? We bridge this knowledge with some of these metrics, like backdoor metrics in a sense, like, and why I call them cheat code metrics is something we could not get anywhere else. Some type of reading, right, that gives us a new insight, like the insight. Like I'm looking for the bridge, the insight, and there's a lot of possibilities, right? But I just haven't sat down and I mean, I have tons of times, but it's just not conducive right now to do that. There's still a lot of understanding I need to go. Like I am doing this solo in a way, yet, distributed with tons of different AI models and the understanding here. But just so you know, right now, that's my goal, is looking for a bridge through one of these metrics that we can use to either reconstruct formulas or something like that. There's definitely something possible to do there. But anyway, so we'll look at, we'll start non-alien, and we'll go to, I think I may have to rerun this cell. All right, so we'll just get rid of this one right here for now. That's pretty much the XOR field. Even though there's a plus in there, we still get the XOR field, pretty much the exact XOR field. Now X plus Y, right? When we get in here, you can already see it, like from back here, it doesn't look that crazy, but already zooming into here, right? We can see complex structure bleeding in. And this is, what this is to me is like, this looks like just a super sheared version. Like if you could somehow like realign all of these lines, you would get what almost looks to me and you'll see what it is the square root field. The square root field has like these fleets, and I can kind of see that here a little bit, but it's just like way smeared and skewed, right? That's just kind of some visual intuition that, you know, looking at the phase, this thing is wild. Like when I first found these, I was like, oh my God, it's 40. But now looking at it, like this is like noise to me now. These are what I call like plaid noise. It's not truly noise at all. Like you obviously can see deep structure in here. It looks like a nested lattice, right? But these are the more uninteresting ones. But obviously it looks fake. Like look at the diagonal here, right? We've got these diagonals coming up right here. And just so you know, there's a lot of prior work here. There's a whole framework I have where not even a little bit of this, but it's like a 1.5D construction, and the FFTs are not even in the same league as these right here. And you'll see what I mean by that, right? This is the same thing pretty much right here. Okay, we're just doing the power spectrum and the log, but they're like the same thing pretty much. It just seems that we can see a little quote unquote deeper into this one. Right, this right here, dominant frequencies, these are going to be, I think, the most important metric right here. I'm kind of trying to naively align them with zeta zeros, but there's not like I'm working on that mapping for that, right? Because right now I'm still kind of exploring all this. This is a lot, like, you know, it's like Disney World, you know. But I've found a lot of stuff right here, but you can already see the irregulars. Like this kind of looks like zeta zero spacing a little bit, like, but it's completely mirrored. Like, so check this out. Like here, like outside of that, look, it's mirrored this way and this way. Look at this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 with the same little spacing. Like I'm not measuring, like I'm just eyeballing that, but you can clearly see, like here's the analogous point right here. 1, 1, 2, 1, 1, 1, 2, 1, right? And then you can and then up here, look at this. There's one right up in here in the corner. You can see that. Not one here. Not one right here. That's a huge key, what you're seeing, like little things like that. That's really telling us something about aperiodicity. And like, if like it's waiting to be revealed, right? You know what I mean? If we scale the grid, that'll pop up. That's already just waiting to be there, right? Phase, really intense. You'll see these will get wildly different in a minute. I mean, I'm talking, you won't even believe how different these will get, but clearly we see, right, in the phase, this kind of, right, Michelangelo, if you will, fingers touching of these cubes right here, right, corners touching. But it seems that seems to be happening at like many different levels, right? These just seem to be on top, right? But clearly there's, you know, you can see this kind of bigger cube structure right here kind of bleeding through. There's one right, really, if you look anywhere, like they're just there, you know, they'll pop in. Metrics, perfect prime, you know, see, you would see, I call that perfect just because it's got a clean, right, big time diagonal angles. Like they really, this 45 degrees pops up a lot. Look at that one slope we saw earlier, that was a way different values. This guy right here, look at that, it's screaming zeta, right? 14.15 is the first zeta zero. Look at this one. So those are naive things, but that's what we need to watch out for. And that's why I have these metrics to like build intuition for some of these values, then apply lots of pressure when I have a better understanding of these values, right? But now I just try to naively pattern match a lot of this stuff, right? But look, and this is just the X plus Y. Like I don't even sit with this one that much. This is literally just because when we do this right here, or we'll just go through the gambit of operators real quick on what it does, right? Where is the dang? There it is. Bitwise exclusive OR is the up caret, not exponentiation. Yeah, already to the wild, crazy, you know, on here with the, what's my grid dimensions? 498. That's fine for now. Right, but look at the FFTs now. Boom. I saw a result of Harvard biologist, this researcher named Sylvie Ruskin, posted a picture of some crazy discovery they made. It was literally this. I'm not even playing. It wasn't literally this. I think they were using an autocorrelation, or their mapping. Like, I even identified like what mapping of color they were using, but I don't want to scoop their work like on here, but I mean, they had this type of structure right here, this like fractal like cross thing. It was in there, and I sent that to them on. They responded at first, and then they didn't say anything after that. After I hit them back up with a more closely aligned image to what they had, and I was like, I think I know what you guys have found. What I think they did was, if you really want to know, they did RNA sequences, much like I'm doing with primes, and did XOR operations with RNA sequences, or something akin to that, and plotted the results, or did spectral analysis of that, and they got this exact thing. Or it's just another, we're just popping into the same structure at the same time, right? But we won't stick too much on that. But clearly, like, I need to be able to zoom into this. Colab loves to glitch out. See, that FFT is indifferent. It's like, it's not the exact logic we were using, but the FFT, see, that's where the complexity lives in the classical system here. The FFTs don't change that much in this one, right? But look, we can see, oh yeah, we'll look at the power spectrum. That's already really complex, right? Bleeding through. Dang, Colab makes me mad sometimes. All right. Right, and then we'll look at the phase already. I mean, it looks like a magic eye. So in my prior work, and I'll prove this to you, in my prior work, in like this thing, so this right here, these guys, this is what I call candy cane banding. Now you can see literally what I'm talking about right here. It's like a perturbation in here, kind of. Looks like a shimmer, like a water effect or something. But these are, in my earliest framework, when I was just taking the number line and folding it into a grid, I would actually like tilt my phone like this. Like, imagine I'm looking at some of my earlier stuff, and I'll do a different video on that, but I could tilt my phone down like this. And I know you can't see my face, but I would go like I'm aiming down the barrel of a gun and look at the image, right? And then when I tilted it literally to this angle, this is the same angle that it appeared, right? The same angle. I saw this candy cane banding right here, and it did not pop up with everything, right? And it's definitely not grid artifact, because this would, like, the primes look so chaotic in that field, but they align to make this possible, this right here. And I observed this in that, and then now I'm seeing it in a different way, like visualized in the harmonic analysis. So I know it's like I saw it for real. Like, I'm not crazy, obviously, with that, because I saw it. But yeah, look, I just traced through all of them right there. But you see it grows, it gets smaller. They're different sizes. It's very reminiscent of the Mersenne prime diagonals, right? But they go straight up the anti-diagonal, or if you're looking at it this way, the main diagonal, right? But yeah, I've seen that pop in, and that's what we kind of see right here. You know, we can see some of that. It's picking that up. So now this is Sierpinski land right here. Let's go to Sierpinskiville. These are wild. So we'll go to X and Y. Look at this. Sierpinski land. Oh yeah, these get crazy. Now you can already just see, but they're a little bit different. See, this looks like, even looking at it from here, you know, clearly 1, 2, 3, 4, 5, 6, 7. Then we got some structure right here. Now it's really starting to pop in. Then you can even see, check this out right here, right? It's like, but look at it. It's perfectly 1/2. See, this is why I think RH is so simple here, right? Because the main motif of all of these is, you know, this 1/2 symmetry, right? I know we're using the number line, right? Because you just imagine the way this is done, right? The number line index right here, but it's done right here, right? On this side, right? Those are orthogonal number lines, right? They're orthogonal number lines. So we get all the information in the integers, what we need. So it's not a grid artifact that this is perfectly, when you light the primes up, there's just two worlds, 1/2, right? Aperiodic structure, but this is, but see, even these, so 1/2 symmetry globally, but there's different worlds here. This is a different world than this one, right? Because look at some of this down here, right? I mean, and here's the thing, I love Legend of Zelda too. So when I was starting to see these, I was like, the Triforce is real. It really is, y'all. The Triforce is real. And it's a Sierpinski triangle. But here we get the claw motifs from the Mersenne earlier. Right here, you can really see it right here. In the other video, I was talking about these in the family breakdown. You can see that right there. But let's juice this thing up a little bit, right? Let's see. Right now we're just X and Y. How do we make it different? How do we make it crazier, right? What do we do? Well, we can first, I'll show you this. X pipe Y. Look what we get. We're still in Sierpinski land, but now we get way different. I mean, we can get, here we go right here. And locally, this will be glyphs, right? So locally, because we're in a weird grid size, we're in Glyphville, and I'm pretty sure that's how it works. I really need to go back and like map that out, like the phase transitions for all this. It's been a little tough because I've still been insight stacking with a lot of this, but we can see zooming in. I mean, absolutely like terrifying geometry kind of. I'm really not going to soften that. It is terrifying geometry in a sense of like, we have no hope in understanding the primes from our old system. I mean, this just proves it. Like, this is beyond, right? Anything we could hope to capture, but it's, this is what's happening in one dimensions too. Whether we like to say it or not, this is definitely happening in one dimensions. We just have no hope of seeing it instead of right here. This is, right, we've got all these little, of course, the inverted, the Triforce, right? Here we got this really interesting, right, zooming in on it, you know, it's just, there's so many, it's so complex. Look at this, we've got these alleyways right here. Very interesting, you know, and we, here's some of those glyphs popping up. We'll look at something in a minute that's real wild. Oh, that one looks, see, it's like this local complexity. Like, that's what we're working in. I feel like what we do in mathematics is working in this local complexity in here, right? We're like all up in here trying to figure out what's going on, and then we'll get some pieces of it, like, you know, but globally, we need the big picture of the primes, and this is the big, you know, this is a slice of this, you know, mathematical object that we're slicing into here. Just with this little rule set of the universe, let's see the mathematical object in this universe. But like, we can, like, you're gonna see, we can get, it gets wild, right? FFT structure for this, I mean, look, crazy. There's two. That's already looking elliptical right there, just at the points. Look at the dominant frequencies now. We got something really interesting here, right? Phase, definitely showing us we're not crazy. Let's here with the phase, look, we can see right, a lot of this stuff right here. Right. So, all right, this one's at 20 minutes. I'm going to go ahead. I'm going to stop right here on this one. And we'll let this just be Sierpinski land analysis. And a few more. Oh, look at that correlation link. It's completely gone now. Oh, shoot. Look at that. Look at that. That's interesting. You don't want to get caught up and be like, that's almost pi, right? I'm looking for that to pop in here. Like one of these is going to be like exactly the digits of pi or something. And then I'm going to be like, right. But that's, well, I'll have to look at that. That's interesting. That's a really interesting wavelength right there. All right. But we'll stop this here and let this be just the Sierpinski visual analysis. The surface level visual analysis. Yeah, they got these. Wow. I'm getting caught up in this one. This is, there's a lot. See, what happens when you add too many metrics in here, you get like frozen looking at, you're like, whoa. So I think this is a good mix. I should have some autocorrelation in here, but I don't want to get too carried away. But all right, Crackpot Chan signing off.